If a procedure meets all of the conditions of a binomial distribution except the number of trials is not fixed, then the geometric distribution can be used. The probability of getting the first success on the x trial is given by the following. The probability of x, which is equal to p times 1 minus p to the power of x minus 1, where p is the probability of success in any one trial. Subjects are randomly selected for a health survey. Now, the probability that someone is a universal donor with group O or type Rh negative blood is 0.17. We want to find the probability that the first subject to be a universal blood donor is the 9th person. So here are the values that we're concerned with, is the 9th and 0.17. So let a success be a subject that is a universal blood donor. To find values of x and p, we know that x is going to equal 9, and we know that p is equal to 0.17. And then we're going to substitute those values for x and p into the formula, and then simplify, and then rounding it to 4 decimal places. So here's our formula, and then we're going to plug in p to be 0.17 times 1 minus 0.17 to the power of 9 minus 1. Now, before we do our calculations, let's simplify what's inside the parentheses. So 0.17, 1 minus 0.17 is 0.83, and to the 8th power. So one way of doing that on our calculator is the following. We're going to take parentheses, 0.17, close the parentheses, times 0.83, and then we're going to raise it to the power of 8, and then that's going to give us this result here. So once we simplify that, we get 0.038288, and rounding it to 3 decimal places gives us 0.0383. Thus, the probability that the first subject to be a universal blood donor is the 9th person selected is 0.0383.